pattern. So we got the conjugate pattern that we practiced. Now we got two more. Notice that these are just the other possibilities. The one that we already did was the A plus B times A minus B or vice versa pattern. Okay, now we're going to do what happens if we do A plus B times A plus B or A minus B times A minus B. So we already did the one where we're multiplying different ones. Now what if we have the same thing times itself, right? Everybody get that? So there's really only three different ways that we could multiply A plus B's and A minus B's. The way we already did, or I could multiply two A plus B's together or two A minus B's together. Everybody see that? That these kind of make a set combined? All right, so what happens? Well, we already know this one, right? What about these other guys? Here's what happens if I expand this whole thing out. If I take A plus B times itself, which is just A plus B squared, or A minus B times itself, notice that the first terms are always going to be A squared, and the last terms are always plus B squared. It's the middle term that you get that's going to be different. You're going to end up with three terms in your answer. So how can we remember what the middle term is? Well, for one thing, and I'm not seeing enough concentration here, honestly. I think like there's some people that are not going to see these patterns and they're going to struggle with this a little bit if you don't just crank it up a little bit and really concentrate. When I expand out these blue patterns, I get three terms that are being added together. Each term has the same exponential power. I get an A times an A, which gives me two things being multiplied together. That's an A squared. I get a B times a B. So that's why I get a squared there, right? Two variables being multiplied together, two things. Or I get an A to the 1 times a B to the 1, same thing. A times B would be the same equivalent to an A times an A or a B times a B. Everybody get that? So in each term, I'm multiplying an A or a B either times itself or times the other thing, okay? A squared term, A times B term, B times B term, right? Okay, so I know I'm going to get an AB in the middle. What's going to go in front of it? Okay, well, there's an easy pattern to follow here. Whatever the exponent is that we're multiplying, that shows up outside, which of course is a 2, because we're just multiplying A plus B times itself, which means squared, or A minus B times itself. Whatever that exponent is, always ends up being the coefficient of the middle term. It's going to be a 2. You'll see that next year when we go a step further and we cube out these things. You're going to end up getting 3's in the middle. You're going to get two terms, but they're both going to have 3's because of that exponent. Okay. The other part of this that you got to pay attention to is, I need a new color here, we'll go yellow, is how about the plus sign? Well, if I'm adding A plus B, then the middle term is a plus. If I'm subtracting A minus B, then that middle term has a minus. Okay, so you see the pieces there? We're always going to get an A squared first and a plus B squared last. That middle term is always going to be a 2AB. It's going to be plus when we have A plus B squared, and it's a minus when we have A minus B squared. So now you guys, so let's take a look at some examples. How about if we jump down to this one, right? So see if you can remember, first of all, what the pattern is that we're going to use here. If I want to expand out 10x minus y squared, keep in mind I could just write 10x minus y times 10x minus y and just distribute and collect like terms. Right? I can always do that. But the shortcuts just make the process a little quicker and more efficient. And you might be tempted sometimes, like in this case, to just multiply it out. But later on, when we start to look at more complicated situations, that's not a good option, right? The distributing and collecting like terms might become way, way too complicated, okay? So again, everybody just click and close, please. Focus up here. What's our pattern going to be for this guy? Which one of those patterns that we talked about yesterday could we apply here? A minus B squared, quantity squared. Good. Okay, so we know it's this pattern. A minus B quantity squared. Now remind me, what is that pattern?
A squared minus AB
2AB.
or 2AB plus B squared.
Okay, good. So then we just need to apply that pattern to our situation, right? So every place where we used to have an A, I'm going to open up a set of parentheses to put our value of A in to that pattern, minus 2 times a set of parentheses to include our value of A, and a set of parentheses for that B in that middle product. And then over here, we're just going to have whatever our value of B is squared. Okay, so in the pattern, what's playing the role of A for us? 10x. So that's going to go there and there in our pattern. What's playing the role of B? Not negative y.
Oh, Y.
Just y, right? Yeah. There and there. And now all we have to do, we applied the pattern, and now we just write the answer down, right? We just simplify that. Okay. You see that that really is a little bit quicker. And when we use more complicated examples, it's a whole lot quicker than expanding the whole thing out, just going through all that arduous work. So what do we get here for our first term then? 10x quantity squared. Give me thumbs. Am I able to distribute the exponent? Yes. How come?
Because they're both X.
Because it's multiplication, right? The 10 and the x are being multiplied. So 10 squared is 100, and then I square the x. Now, how about here? I'm multiplying three things together. Minus 2 times 10x times y. So what am I going to get for my number? Negative 20. Yeah, and then I've just got multiplying by an x and a y, right? And then finally, I just get plus y squared. And we got it. No big deal, right?